Hello everyone. In the previous video we understand and we learn about what is RAGAS. So RAGAS are basically the rag assessment. So what exactly we are assessing? So we want to check whether the answer is generated or the data is generated by the rag is not hallucinated. So for that there are certain metrics which we use to validate against, and one of the metrics which we checked in the previous demo, which I have created a manual function to how it works, is the faithfulness. So how it works basically, it basically extract your answer, verify it, and calculate the faithfulness. Now who is extract and who verify is basically the judge model. And who is the judge model? The judge model, we are using the Claude Sonnet in that case. So I'll show you once again. So at manual. So yeah, so here it is claim extraction. So here is the judge model. When who is the judge model is Claude Sonnet 4.5. So first step is to extract the claim, the second is to verify the claim whether and it is correct or not, and the third is the calculate the faithfulness, and the formula is like supported is divided by the number of claims. So that's how we calculated, and it was a dummy function which I just wanted to show how the faithfulness works. So now coming to the actual libraries, how the industries use the RAGAS to test. So there are certain libraries which we have to use, like RAGAS is basically the Python library which we used to evaluate length chain, LLM wrapper, embedding wrappers, faithfulness, answer, relevancy, and these are the 4 different metrics. So in the last video we just cover faithfulness, and now in this video we are going to cover all rest of the 3 as well. So faithfulness, answer, relevancy, context recall, context precision, and the other libraries. So before that, I just wanted to tell you one more thing, like for this demo I have created a data set of question and answers, around 50 or 60 questions, which is again created using the Claude, and they are using with my Distilbert classifier. As you can see, the classified as static, which we have discussed how we are doing that classification. And there are other things which are important here is like one is ground truth, which basically this ground truth is generated by the Claude, and the answer is generated by our model, and the context is basically is nothing but whether it is coming from the knowledge base or static. So that's what it is coming. So here you can see, I can show you one. Okay, so how many cities will host games in 2026 World Cup? So the context is World Cup. So this is something coming from our GRPO model. Answer is coming from Claude, and the ground truth is also coming, and the expected source is knowledge base, and live data as classified. So these are the things which these are the questions which I have created. Now coming back to the how it works basically. So these are the 4 things, four metrics. So faithfulness, as I have discussed in the previous demo, like how it works is basically it takes the answers as I showed in the data set. It takes the answers, it convert into claims, verify it, and check against the context. And the context, as you can see here, this is the context. So for some of the cases the context is empty, so we are going to skip those things. And the next metric is answer relevancy. So how answer relevancy works is basically, so answer relevancy is kind of a reverse engineering. So for every answer we create, or not we, like the judge model creates 3 questions. So I can show you here. So this is the answer relevancy. So as you can see, there is a real question here: how many cities will host games in 2026 World Cup? And so the answer is United States will host 2026, and the question is how many cities. So we are expecting a number like 16 or 20 or some kind of a number. So for that there are 3 questions generated by Claude. One, where will 2026 FIFA will be held? which country will host the next FIFA, and what major sporting event is coming to United States. So all these questions. Now we are going to embed this into database using the embedding into vector database. The embedding is mxbai, and whatever the we are getting the embedding distance, that's what we are taking, getting the mean, and that is 0.799, which is, and so because the answer contains Kansas City, and that's why it is having one of the answer is having 0. One of the question which is close to the answer is 0.896. The next question is who helped Rama rescue Sita. So as there is no context and there is no answer for this, so it gives like I don't have the information, and these are the questions it generated. So again this is a very small uh, cosines and versus real questions, so that's why the answer relevancy is 0.32. Now the next question is what is the weather today in Columbus. So it is giving the answer is beautiful sunny day, the temperature is 74 and perfectly and dot dot. So here it created three questions and generate the cosine similarities and get the answer relevancy. So as you can see here we are getting 0.799, 0.3. So it is 0.799 is little hallucinated because it is not up to the answer, because the question is how many cities. So we were expecting the number like 16 or 20, but we got the name like Kansas City. So it's little hallucinated, but at least it give the name, little bit information is there. The next question is honest Rama. It does not have any answer because it clearly says I don't have information, so got the answer relevancy 322, 0.3. And the third one is the weather today. So the weather is 0.678. And why 0.678? Because it did not show because the answer contains something like perfectly to play outside. That is something is the model is creating by itself, the RAG is created itself, so that's why it is little out of the question, and that's why you can see the number. So that is the answer relevancy, where the judge model create do the reverse engineering, creating the three questions for the answer they are giving, and that's where it get the cosine for all the embeddings and get the average. The next question is context recall, next metric. So as you can see in the data set we have the ground truth, or I can call it GT. So that is very important because that is something is added by Claude. So the first is context recall, and the context recall is basically check the GT against the context. Okay, so it basically doing the same thing what we were doing in the faithfulness. It basically take the ground truth, the scientists believe that's one of the statement, it extract, verify it, and calculate how we were calculating the faithfulness, so with the same logic. So that's how the context recall works. And the another matrix is context precision. So context precision is basically like it takes the context and it basically get the same, extract it and validate against the question plus the GT, and where GT means the ground truth. Now here is the thing, when we are going to integrate this with the live RAG pipeline, we are not going to have the ground truth and all these things. So that is something is we will discuss how we will integrate that with the pipeline in the next demo. But just to tell you, there are two approaches. One is I can call it tier 1 and tier 2. So in the tier 1 we can contain only these two, faithfulness and the answer relevancy, and in the tier 2 we can contain all four of them, or we can say context recall, because context recall and context precision requires GT or the ground truth, which is not available in the live data. We only get the answers and the context. So with the live data we will use only these two metrics, but over the nightly build we can actually check all the answers against all the four metrics, and that is something I will show in the next demo. So if I'm going to run now, so I am going to run this file, but again because it is as every matrix is making the call to the judge, and so if I'm going to run with all the 60 questions it will take a lot of time. So I have selected only 3 questions and I'm going to run against that. So how that works basically, okay, So as you can see here, so loaded 60 questions, evaluating step 45 because no context and the context is empty. So it is running to cloud calls, so expect several minutes. As you can see, when we are running the faithful, it is extract first thing, so that is a just call, then it is verifying, that is again the just call. Same thing for relevancy, it is taking the ground truth, extract it, just call, claim, verified, just call. So likewise there are multiple calls. So here I'm selected only 3 questions, and that's why you say 12. So 3 multiply 4 matrix, so that's why it is 12. So once it will completely complete, the output will be something like this: faithfulness 0.056, answer relevancy 0.930 for the questions which I have selected. And so here are the questions which I have selected. What is 7 times 8? So 7 times 8 is basically, can show you here what is 7 times 8. Okay, so as you can see, it is saying it's a live data, so definitely the classifier did not work correctly here. It should be simple. So ground truth is simple, GT is simple, 7 times 8 equal to 50, but the context and is given by our model is definitely not correct. So that's why, so the it validate the answer against the context in the faithfulness, so that's why it is 0. It's nowhere connected to the answer. Now the second thing is, are there any big soccer games today? So here is the again, so GT verifies soccer matches occurs daily across various leagues worldwide, with specific game depend on the current season and date. This is again the correct classification. It's a news and live data, but the context and the answer does not match. TV channels, it is not giving correct, so that's why it is giving the relevancy 0, faithfulness, and it's hallucinating. And how many cities will host games in 2026 World Cup? You can see here. So here it is, context, answer is, here is your answer, the United States will host, the Kansas City will be selected. The question was how many cities, not which cities. So the answer is supposed to be like what we have in the GT, that 2026 hosted across 16 cities. So nowhere it is related to mention the 16 cities, but it mentioned the Kansas City. So as you can see how we have verified the faithfulness, it claim, extract and calculate that, and that's why you can see the faithfulness, or the faithfulness for this answer is 0.17, because 0.17, because it has the name of one of the city called Kansas. So that's how it is working. So it is still running out of 3. So that's how it we run all the 4 matrix again in the RAGAS. Now again, let me repeat, for the live data we are going to run only the 2 matrix, that is answer relevancy and the faithfulness, because that does not require GT or the ground truth. But for the overnight, the data set, which will time to time it will increase, because we are going to verify and we are going to add more data, so the data set will increase. So overnight we will run, and the all the 4 matrix and get the data. So ground truth is curated by the human, that is like people create the data set and validate against that. So that's important thing, that we have to create a data set. And so that is something we are going. So in the next video I'm going to show how to integrate the live data with the faithfulness and the answer relevancy, and to show, just to